I'm audible to you?
Yes, sir.
Okay, so let me continue. So we were solving examples on the normal distribution. To solve the examples, we have to start with the z equal to x minus mu divided by sigma, where mu is the arithmetic mean and sigma is the standard deviation. Then we understood the concept of what the normal distribution is that we have to use. Okay, assume, right? Next example. The mean height of soldiers to be 68.22 inch with variance of 10.8 inches. How many soldiers in the regiment of 10,000 would you expect to be 6 feet tall, where
Sir, is it 108 inches or 10.8 inches?
10.8. So area is given. Solution. Run. Let arithmetic mean standard deviation okay to find what is our aim, find number of soldiers having height more than 6 feet. 6 feet means 72 inches. Yes, find this value. How much is this? Yes, how much is this?
0.35.
0.35. Then why this 1.15 is given? Let me check the table. One minute. 0.35. 0.35.3. Zero 0.35, na?
Yes, sir.
Yes, sir.
1368. 1368. 1.15. 1.1. It's a okay. So right given sorry. I'm wrong. Variance is given, not the standard deviation. So what is the relation between variance and standard deviation? Variation equal to sigma square, right? Na? So variance is given and sigma is to be obtained. So it should be sigma equal to root of v. So root of 10.8. Now find this. What is the root of 10.8?
3.286.
3.28. So this should be 3.28. Hope you might have understood. In example, variance is given with variance of 10.8. And our aim is to consider sigma, standard deviation. So it is a root of 10.8, that is 3.28. Now find Z1. So instead of dividing by 10.8, divide by 3.1.
1.15.
Yes, correct. Now we'll go ahead. Now, right, according to normal distribution, probability that a soldier's height sorry is more than 6 feet. Okay, so probability of x greater than 6, probability of z greater than 1.15. So probability from 1.15 to infinity. Z equal to 0. Z equal to 1.15. More than 1.15. So our aim is to find this area. So that may be written as probability from Z equal to 0 to infinity, right? This total probability minus probability from Z equal to 0 to 1.15. Right? This is always 0.5 and this is provided to us 0.3749. Yes, what is the probability? 0. Anyone?
251.
0.
1251.
1251. Okay. Now number of soldiers whose height is more than 6 feet. 1251, right? This is probability for one soldier, but how many soldiers we have? 10,000. This is the answer. Now written. Next example. Let me change the page. 83, now 84. Page number 84. Right. Write with me. A random sample of 200 bulbs, 2000 electric bulbs. It was found that the life of a particular make, say particular company, was normally distributed with an average time 2040 hours and standard deviation of 60 hours. Estimate the number of bulbs the number of bulbs likely to burn for okay, great. Chalo, madam. Solution. Let here arithmetic mean 2040. Okay, then to find the number of bulbs whose life is between 192 hours to 2160 hours. I am audible, na?
Yes, sir.
Hope everyone is here. Hope that you're not done that. Started the mobile, kept it aside, and you're doing your work. So that will not help you. You now get prepared for offline exam.
-2
-2, na?
Yes, sir.
Right, na? Yes, this much area we want to find. So probability from -2 to 0 and from 0 to 2. So by symmetry, and that is known to us. Given an example.
Point 9544.
0.
0.9544.
Number of bulbs. Nine five four four into how many bulbs are there? 2000.
One nine zero 8.8.
19088. काय चुकलं ना? Correct ना?
0.8 है, sir.
अच्छा. So approximately. So out of 2000 bulbs, 1909 bulbs are expected to burn for at least 1920 hours and maximum 2160 hours. I think you might getting the problem. Okay, we'll go through the next part. Just 1 minute. ओके चलो स्टार्ट करते हैं लास्ट पार्ट ऑफ द टॉपिक सो अच्छा let me start the recording once again or it is okay right chi-square distribution notation for chi so a few definitions are there first we'll go through the definitions and then we'll see what we can do right it is written like this also huh? chi square chi square but it is not chi it is chi square it is used for testing goodness of fit of a model. The variable is denoted by where n is degree of freedom. Right. The chi-square variate is defined as sum of squares of an independent standard normal variables. Okay. Then next hypothesis. A claim to be tested is known as hypothesis. Okay, then two types of hypothesis. Null hypothesis denoted by H naught. A hypothesis of no difference. Is known as it is claim expected to be checked. Right? Null hypothesis is the claim that we are expecting to be checked. For example, suppose marks of student of civil engineering are given, and I am saying that the average marks in same exam conducted for 30 marks. So I am saying that average marks is 20. Okay. So H naught is average marks of the given data is 20. What will be H1? Alternate hypothesis, average marks is not 20. Okay, so second is alternate hypothesis. Denoted by H1. It is a hypothesis to be accepted when H naught is rejected. Okay, so the alternate hypothesis is written in such a way that whenever H naught is rejected, we have to accept H1. Okay, then errors. Right. Since now see in statistics, what we are doing, we are collecting some data and then we are approximating it. And whenever we are approximating some data, there is chances of the errors. Okay. So since decision of acceptance or rejection of H naught is based on sampling. What type of sample we are taking depends upon that. For example, after some say Lok Sabha elections are there, and after that exit polls are taken. Here you might know that. Then it is not possible to go to every person of the India. No? We cannot reach to the 80 crore persons, voters of the India, and ask them to whom you have given the vote. It is not possible. Okay. Then a sample is taken. So, for example, say the views of say 7-8 lakh people are taken, and from them the conclusion is obtained. Right now, so it depends upon what type of sample is chosen. Okay. So it is subject to two kinds of error. Type 1 error. Below that, write down. Rejecting H naught when it is true. This is known as type 1 error. type 2 error. Accepting H naught when it is false. Then next, level of significance. LOS. The probability of rejecting H naught. See the type 1 error, rejecting H naught when it is true is called as level of significance. Thus, it is probability of committing type 1 error. Type 1 error is just it is error. Okay, and here in case of level of significance, we are finding probability. It is
Sir, can we say that type 1 error falls under LOS?
No. See, error is different. Error is some number. Say absolute, that is absolute error. And in case of level of significance, we are considering probability of error 1. Probability of error of type 1, like this.
Yes, sir.
Now, right. If we try to minimize level of significance, that is the type 1 error. The probability of type 2 error increases. So, LOS cannot be made 0. But we can fix it at 5%, that is 0.05, or 1%, 0.01. Usually it is taken as 5%. Hope all these things are clear. Then next formula. Chi-square k minus p minus 1 alpha is given in example. At alpha level of significance. So what are the possible values of alpha? Maybe 1% or maybe 5%. Usually we take it as a 5%. This is one value. Okay. Now write down. Obtain. Understand the difference. Chi-square k minus p minus 1 equal to, so here alpha is not involved, huh? Equal to summation of OI minus EI whole square divided by EI, where observed frequency. All right. And then EI, expected frequency or theoretical frequency. Okay. Then K, number of observations. Then let P, number of calculations done so that EI is greater than 5. Right, expected frequency, it should not be less than 5. It should be greater than 5. And usually for whatever examples we are considering here, in M3, for all those examples, P equal to 0. No any calculation is to be done. So from there we can find this K minus P minus 1. That is degree of the freedom. Okay, then on the next page, right? I do understand at this moment it is difficult for you to understand what exactly is going on. So keep patience for some time. Right, next. So now we have two different values, huh? You might have understood. We have two values. One is chi-square k minus p minus 1 comma alpha. That will be given in example. And this summation value, which gives chi-square k minus p minus 1, that we obtain. Okay. So on the next page, Radha, when which is calculated value. Which is given value. Then H naught is accepted. Right, when H naught is rejected and then H1 will be accepted. We'll start with the example and then we'll understand these things. Okay, we'll go through example. Chalo, example solve karte hain so that we'll understand it. Okay.
फर्स्ट केस मध्ये टाइप 2 एरर आलाय का म्हणजे प्रोबॅबिलिटी
कशामध्ये
फर्स्ट केस व्हेन काय स्क्वेअर के मायनस
करेक्ट नाही एरर चा इथे काही प्रश्न नाहीये देयर इज नो क्वेश्चन ऑफ एरर ना H naught is accepted, that's it. What is error? H naught is accepted though it is true. That is error. That we have kept at the level of significance alpha, and alpha we are taking as a 5%. So we are considering that whatever answer we will obtain, that is up to 95% it is correct. Whenever alpha is 5%, meaning is that whatever answer, whatever conclusion we obtain, it is not correct exact conclusion. Sometimes their whatever conclusion we obtain, that may be wrong. But up to how much extent it is correct? 95%. 5% error may be there. Understood or not?
Yes, sir.
Okay, chalo. We'll go through example to understand this. A nationalized bank. So start with example. This is okay. Uses 4 ATM machines. On a particular day, $800 customers were observed. They were given service at different ATMs. Test whether customers are uniformly distributed over the ATMs. Given solution. You might have observed that. Can anyone tell me what the answer is? The customers are uniformly distributed or not? Is it possible to find any conclusion from whatever data we have? Customers are uniformly distributed or they are not distributed? Anyone?
Not distributed.
Okay, any other answer? Yes, any other answer? Right, define hypothesis as H naught. Customers are uniformly distributed. What is H1? Customers are not uniformly distributed over different ATMs. Over different ATMs. Okay. Okay, now table is required. We'll write that on next page. I think after this you are free, na? Free ना आप इसके बाद?
No, sir.
क्यों क्या है अभी?
Sir, to prepare for this.
Prepare for what?
Yes, sir.
Prepare for what?
Sir, unit test.
Unit test is simple. So nothing difficult in unit test. OI, huh? Observe frequency. Total is 800. So what is the expected frequency? Means how many customer should be served at a particular ATM so that it will be uniformly distributed. Total is 800, na? And divided by how many ATMs are there? 4, so 200. So if every machine, ATM machine will serve 200 customers, then it will be uniformly distributed. No doubt, it is not possible. Yes, find these numbers and see what their addition is. OI minus EI divided by OI minus EI square divided by EI. Please do it yourself. Check your numbers. Is it like this?
34.
Yes, your answer is like this. Is it 34?
Yes, sir.
Okay. Then write down here. K, number of observations. 4. P, number of calculations done when EI is less than 5. But all EI, they are 200. So no any calculation. So degree of freedom. What is degree of freedom? K minus P minus 1. Okay, so chi square 3 equal to OI minus EI square divided by EI. That is equal to 34. Thus, chi square 3 equal to 34 and chi square 3 0.05. The calculated value, given value is 7.815. So, what is conclusion? Calculated value. This is given value. So, given value is smaller. So, H naught is rejected. So, H1 is accepted. समजते ना सर्वांना? Getting everyone ना?
Yes,
So, what
sir.
is conclusion?
No, sir.
काय झालं?
नाही समजलं सर. It's not easy.
एकच मिनिट. Customers are not uniformly distributed over different ATMs. अच्छा, काय समजलं नाही सांग. Have you understood the table?
Yes, sir.
How this 200 obtained, have you understood now? How expected frequencies are obtained? If 200 customers will be there for every ATM, then it will be uniformly distributed. From there it is obtained. Then using that, the last column is obtained. OI minus EI square divided by EI. And their addition is 34. This is okay? Yes. This is okay?
Yes, sir. H naught is rejected.
Then K is the number of observations. Just 1 minute. K is the number of observations. 4 observations we have. Okay. Then see the EI 200, 200, 200, 200. Okay. So P. So calculations not required since all the EI are greater than 5. So 0. So degree of freedom is K minus P minus 1. That is 3. And that we can obtain from the given values also. Na? See the given value. Here we have 3. Na? So this here also we should have 3, but we have to understand from where we are getting this 3. Okay. Then this chi square 3, that is we have calculated it is 34, and the given value of chi square 3 at 5% level of significance is 7.815. So no doubt calculated value is greater, and before some time we written that whenever calculated value is greater, H naught is rejected. And therefore H1 is accepted. And what is H1? Customers are not uniformly distributed over different ATMs. Now understood?
सर कधी कधी अशा पण देऊ शकतात ना अल्टरनेट व्हॅल्यू जसं की आता आपल्याला चाय 3 होल स्क्वेअर चाय स्क्वेअर 0.05 म्हणजे अल्फाचं जे आहे ती व्हॅल्यू दिली होती, तर मग पुढच्या वेळेस असं पण सांगू शकतात ना की अल्फा फाइंड आउट करायचा वगैरे?
नाही 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 अल्फा वगैरे नाही. आता ते त्या लेवलला आपण जायचं नाही. ऍज अ इंजिनिअरिंग स्टुडंट दॅट इज नॉट एक्सपेक्टेड. नाही ते नाही आहे ना.